All right, so it's great to be back, and thank you for the opportunity to discuss this paper. Let me first briefly summarize it. So the starting point is that data is a production input, but it's a little bit different from other production input in two respects. First of all, it's non-rival. So different firms, multiple firms can use the same data. And it also has network externalities, right? And the way firms share this data is through this software development kits, SDKs, that are basically attachments to the apps that they deploy, right? So what is the key question? So the basic question basically is, well, we have this data sharing, right? What are the effects, right? What are the outcomes? For a lot of different dimensions, right? For valuation and growth of firms, for co-movement in firms, operating, financial, and accounting performance, and for the propagation of different shocks, across the data economy. Let me skip the slide about SDK. I think Huan explained it very well. What is the sample? So we have 1,000 firms that have apps on the Apple ecosystem, and they account for about 60% of CompuStat assets. So let me start with the first comment, which is maybe a little bit of a cheap shot. I think the 60% is a bit of an overstatement. So a lot of firms have apps. But if you think about, for example, the largest firm in the economy, NVIDIA, it has 3 apps on the Apple App Store. They're very tangential to what the NVIDIA actually does, right? They're not very important for NVIDIA's operation. I assume that there are some other firms, that are quite similar in that. So the actual impact of this data sharing might be a little bit smaller than the 60% that's in the paper. But clearly, it's still very, very important, right? And then basically, the first thing that the authors do is they construct this network of data sharing across firms. It's basically a cosine similarity between SDKs that firms employ weighted by the number of users across the apps that say firms has. All right, what are the main empirical findings? So first of all, firms that are data connected through SDK, they have lots of co-movements with other firms connected with the same SDK, right? Across, again, many dimensions in terms of kind of operating performance, the downloads of the apps, the daily engagement of the users, the growth in earnings, the stock price or returns, right? Pretty much those firms are connected in everything, right? And also, if you think about other types of connectedness, right, this type seems to be much stronger than any other. I think they have 7 or 8 other types of connectedness that they look at, and connectedness in terms of data sharing seems to have the largest effect of them all, right? And then they have this natural experiment, this app tracking transparency introduction by Apple in 2021, which basically reduced or almost eliminated the possibility among firms to share data, right? One final result is kind of about the propagation of shocks. They look at cyber attacks that firms are subject to and see how that affects firms that are connected to the affected firm, to the attack firms, along this data connection network. All right, they also have a model. I'm going to go over this very briefly, and then I'm going to go to the comments. So data, again, is a non-rival asset that is generated by investment by firms in engagement, right? So firms that have this intertemporal kind of substitution problem, they can either invest more in creating more data, or they can invest more in generating your earnings from existing data, right? And they have this decision that they make over time. And data is shared again via this exogenous network of SDKs, right? Firms do not choose in the model with whom they share the data, right? They do choose how much data to produce and how much user engagement to create, right? And the reason they want this data is that the more data there is, the better they can basically target users, right? It basically improves the prediction of what users want from the firm's product, right? And that basically feeds back into their production function, right? How much they want to invest in generating new data and how much earnings they're going to generate as a result, right? The effects of data propagate through the network, right? Because firms use not just their own data, but a processed data of other firms in the economy, right? And basically that leads to kind of higher order effects, right? There's going to be dynamic kind of propagation of data through the network, improving firms' decisions and also their valuations. All right, so why do we really need the model? Well, the first thing is, well, provide a rigorous explanation of the mechanisms that we just described, right? This by itself, I don't think justifies the model, but it's a nice way kind of to show this mechanism. However, the model also produces many novel or new results that don't come out of this kind of simple discussion, right? The first one is that basically the systemic importance of firms depends not necessarily on the size, but on the placement in this network, right? The second is that you can basically decompose firm value into its own data production, right, versus the data, or in addition to the data that firm uses collected from other firms through SDK. A nice kind of result, which is quite intuitive when you read it, but it was not intuitive to me ex ante, is that firms don't internalize the externalities that they produce, that their data production has on other firms, right? So basically underinvest in production of data relative to what the central planner would do. And the final result is that these design choices lead to herding by firms, right? So firms co-invest together in production of data, right? And that comes from this data sharing mechanism, right? And finally, there is a calibration exercise whose point really is to identify systemically important firms whose data production is kind of crucial for the whole economy and for the other firms in the economy. All right, so the way I kind of think about this model is a combination of two types of models or two types of literatures. The first one is a literature of switching costs. The basic idea is you invest now in order to increase your profits later on, right? So this is kind of a very simple canonical trade-off, right? So here the investment is in data. Now, one twist obviously is that data is not a normal production input, right? It's non-rival. And it's potentially complementary across firms. I say potentially here because I'm going to have to, a couple of comments about that later on. And then the second kind of type of literature is a literature about information sharing. There is a big literature in the economics basically describing the pros and cons of sharing information among firms. So clearly, we want other firms' data, but we don't necessarily want to share ours. Now, there are a couple of twists here. Or maybe kind of simplifications, right? The first one is that here sharing decision is exogenous. Firms don't really choose in the model with whom to share data. And the second one is that the model basically focuses on just the benefits on sharing the data, not necessarily on its costs, right? So let's think about what would happen if we if you remove this kind of this limitation from the model, right? And of course, it's easier to talk about expanding the model than to actually do it, right? But let's just think about this direction, right? So currently, firms choose how much data to produce at any given point in time, but the data sharing network is exogenous, right? And fixed over time, right? And so what the model really abstracts right now, and it's very clear, and the authors don't hide this, is there is no selective data sharing, right? The firms cannot really choose what types of data to share, and sometimes in reality they do have the options to share some parts of data without sharing others. And secondly, kind of strategic withholding of data components is not allowed, right? So the first one is about with who to share, the first bullet point, and the second is what data to share. Now, what would happen if data sharing was endogenous, right? So then we'd get, I think, to some interesting kind of dynamic effects, right? So firms that would initially accumulate a lot of data would be less likely to be willing to share this data with others, right? Their data would be enough, and they won't rely as much on the data produced by other firms, right? So they would be less likely to participate in this data sharing networks. And as a result, data sharing networks would probably become more sparse over time, more fragmented, and also feature more firms that are kind of poor in data production, that don't have a lot of data and have more to gain from being part of these data sharing networks, right? That also means that the spillovers, network spillovers, would probably weaken over time, right? And the importance would probably shift away from initially systemically important firms, right? They would kind of leave the network or participate in them less, right? And shift to other firms that are initially data poor but kind of participate more heavily in those networks. All right, so why do we really need information or data in this model, right? data basically allows better precision of predicting what the user really wants from the firm's product, right? Now, what the data does not do in this model, right? It does not have any strategic impact on the firm's behavior, right? It doesn't affect the pricing of products. It doesn't affect the choice of the products that the firms issue, right? It doesn't have, the model doesn't feature any kind of stealing of information, right? So basically, it doesn't really have an impact on competitive strategies, right? Now, why might this matter? Well, data sharing in the model has a pure positive externality, right? It doesn't have any kind of any bad side to it, right? This information sharing trade-offs might be important in reality, right? The thing I discussed, that you might not want to share your data because you think that it's going to benefit your rivals more than you're going to gain from data of your rivals, right? Now, I don't know if it's possible, but I think it would be interesting to extend the model to basically somehow impact the optimal pricing of products, right? And that would probably introduce some negative externalities on data sharing, right? And it's going to have ambiguous effects. I wrote welfare here, but it's really going to have a lot of ambiguous effects, that could be interesting to study. All right. Now, of course, any model is, limited in its assumptions, right? It has some simplifications, and that's fine, right? But let's think for a second. What are the settings for which this current model can apply better versus settings where it could apply worse? So I think the settings that are most appropriate for the current kind of type of the model, right, are settings where individual firm data is scarce, right? So firms have incentives to join those information sharing networks. There is a reliance on third-party SDKs as opposed to SDKs produced by firms themselves. So Facebook and Google have their own kind of SDKs that they themselves run. It's also, this model kind of is applicable, I think, to a setting where firms have limited ability to really control the amounts and, well, the types of data that they supply to the network. And when there is not a lot of interaction in terms of kind of strategic decisions between a firm and its rivals, right? So this basically is a situation where I think this model kind of fits well and can be used, as is. However, if we think about settings that are not like that, right? So if we're thinking about firms that are data rich to begin with, think of Meta, or that use vertically integrated platforms that kind of allow data sharing within a firm. Or when firms can choose what type of information to disclose, or when there is a lot of strategic interaction among firms, well, then maybe we need to think about what the effects of expanding the model will have. All right, a little bit about the empirics. I have a couple of minutes. All right, I'll start with the fact, right? So the fact is that this overlaps in SDK, explain co-movements, different types of co-movements, better than any other overlap, that you can think of, or any other similarity, right? And you also have this natural experiment, right, that those co-movements drop sharply after this introduction of ADT, right? The interpretation is that data sharing is responsible for the co-movement among firms, right? And that may well be true. However, there might be some alternative interpretation. For example, SDK overlap, right, might proxy for similar exposure to shocks, right? Think about, the top one, the first and the third firm in importance in this network, right? I'm talking about Meta and Snap. Both of them are operating social networks, right? And it's likely that they're interested in the same or similar data about advertising and in the same kind of processing of their data, right? So they might be exposed to the same shocks, right? And also very connected in terms of their kind of SDK overlap, right? And so it is possible that, data sharing is responsible for co-movements, but I'm not sure that the paper necessarily kind of proves this point. Same thing goes for the natural experiment, right? When we have this reduction in data sharing, basically data becomes noisier, potentially biased, because we don't really know who opts into kind of sharing the data. And more idiosyncratic, right? There is just less overlap in terms of what data the firms collect, right? And so the commonality of shocks decreases, right? And we see less co-movement, right? Now, there might be one way around it, right? Basically try to relate the reduction post-ADT in the extent of co-movement to the opt-in rates that you can measure at the app level. All right. The results generally are extremely strong, right? So once we introduce this shock of reducing data sharing, right, all of the co-movements goes to roughly 0, right? Now, is this surprising? To me, it was a bit surprising, right? Because basically, this is not the only way firms share information, right, through this Apple apps. There's a lot of other ways to share data. There is data sharing on Android devices. There is web-based data sharing, although it has some limitations. And also, firms are still subject to the same shocks, right? So if you think about, firms that are not as kind of reliant on this data sharing through apps, think about, NVIDIA and AMD and Intel, right? They produce chips. All of them have some apps, right? But their kind of connectedness might less be due to those information sharing through the apps, right? But through the common shocks, right? So basically, I think the result that all the effects go down to 0 are a bit surprising to me and maybe require some explanation. One more time, right? All right. So let me just. There are a couple of other kind of ideas that I had, but let me just conclude. A really impressive paper, and it makes you think a lot about kind of the evolution of the new data economy and how sharing the data basically changes, firms' decisions. Right? Thank you.